Welcome back for another deep dive. We love to mix it up here, and today we're taking on a listener request, which is always fun. We're going to be exploring fog,
Oh, very cool.
specifically the chemistry behind it.
Hmm.
Have you ever, just been outside on a foggy day and it's like, whoa, everything's just transformed by this, mysterious mist?
Yeah, it's definitely got an ethereal quality, doesn't it?
Totally. And so today we're going to, pull back the curtain and look at what's actually going on, at the, molecular level.
Yeah, the chemistry behind the curtain.
Exactly. So I guess, maybe just to start us off, I've always heard fog described as like a cloud at ground level.
Hmm.
Is that accurate? Is that a good way to think about it?
Yeah, I think that's a great place to start. I mean, essentially, that's what it is. We're talking about tiny water droplets suspended in air, and that's what makes up a cloud, right? So when that same phenomenon happens at ground level, we call it fog.
Okay. So then, what keeps those water droplets from just, falling to the ground? Why are they suspended?
Well, that's where we get into the chemistry a little bit more.
Okay.
Those water droplets need something to condense on. And
Okay.
these are called condensation nuclei.
Condensation nuclei?
Yeah, so these are tiny particles that are floating around in the atmosphere, and the water molecule can basically latch onto them and start to form droplets.
So it's like they need a little something to, get them started?
Exactly, like a little platform to build on.
That's so cool. So what are these, nuclei? What are they made of?
Well, they can be made of a variety of things. Dust pollen, sea salt, even pollution.
Wait, pollution? So, our car exhaust is contributing to fog?
Yeah, in a way it can, but remember there are a lot of natural sources of condensation nuclei too.
Oh, okay.
Like volcanic ash, for example.
Oh, I never would have thought of that.
Yeah, it's pretty amazing.
Okay, so we've got these little, platforms, these nuclei that the water droplets can form on. But what else is going on? Why are some places foggier than others?
Well, you're probably thinking about humidity, right?
Okay, yeah.
Humidity is the amount of water vapor in the air. And the higher the humidity, the more water vapor there is to form those fog droplets. So basically, the more humid it is, the easier it is for fog to form.
Okay, so it's like you need all the right ingredients, right? You need the nuclei, you need the water vapor.
Exactly. It's all about the right conditions coming together.
I like that. So we've got the nuclei, we've got the humidity. Anything else? I've noticed fog tends to form in valleys or low-lying areas. Why is that?
That's a great observation, and it has to do with something called a temperature inversion. Basically, it's when you have a layer of warm air sitting on top of a layer of cold air.
Okay.
The warm air acts as like a lid, trapping the cool, moist air below, and that's where the fog forms.
So the warm air is like a lid keeping all that fog in.
Exactly. And because cold air is denser, it tends to settle in those low-lying areas like valleys. That's why you see a lot of fog there.
Oh, that makes sense. Okay, so now I'm picturing this, these droplets forming on these nuclei trapped in these valleys by this warm air lid. But why is it so hard to see through fog? We all know driving in it can be pretty scary.
Yeah, for
What's
sure.
going on there?
Well, it's because of how light interacts with those water droplets. The more droplets there are, the more the light gets scattered, and that makes it harder to see through.
So the denser the fog, the worse the visibility.
Exactly. And, that can make driving in it really dangerous because you just can't see as far ahead.
Right, yeah, for sure. Wow, okay, so we've covered a lot already. We talked about the water droplets, the condensation nuclei, the humidity, those temperature inversions. It's pretty amazing how all of that comes together to create fog.
It really is. And we're just getting started. There are all sorts of fascinating types of fog out there with their own unique characteristics.
Oh, okay, I'm intrigued. So what are some of these unusual types of fog? I've heard names like pogonip and hair ice. What are those all about?
Those are great examples. Hair ice is a really cool phenomenon where ice forms on dead wood in these delicate hair-like strands. It's almost magical looking.
Whoa, hair ice. I've never even heard of that.
Yeah, it's pretty amazing. We can definitely dive into that more.
Yeah, please. And what about pogonip?
Pogonip is actually a type of frozen fog. It happens in extremely cold and dry conditions, and those tiny water droplets in the fog actually freeze into ice crystals.
Whoa, so it's like super fog.
Haha, yeah, you could say that. It creates this thick white haze, and it can be really beautiful but also dangerous because it can reduce visibility significantly.
Okay, so we've gone from the familiar, fog rolling in on a bay to these, almost mythical sounding types of fog. This is so cool.
It is. The world of fog is surprisingly diverse.
Well, I'm ready to dive deeper into these unusual types of fog. Where should we start?
Let's start with hair ice. It's a great example of how even in the coldest conditions, nature can create something truly beautiful.
Okay, I'm all ears. Tell me everything about this hair ice.
All right, so to understand hair ice, we need to talk about a specific type of fungus. It's called Ixidiopsis epusa, and it likes to hang out in decaying wood.
Okay.
And when the conditions are just right, like below freezing, but with a bit of humidity, this fungus releases a special
A
substance.
special substance. Okay, what does it do?
Well, it basically prevents the water molecules from freezing into like big, ice crystals.
Okay.
So instead of forming those chunky crystals, the water freezes into these really thin, delicate strands.
Oh, wow. So it's like the fungus is like sculpting the ice into these like hair-like shapes.
Yeah, that's a great way to put it. And the result is pretty stunning. You get these like white, silky strands of ice coming out of the wood, sometimes several centimeters long.
That's wild. I've got to see a picture of this. Okay, so we've got hair ice, which is like delicate and kind of magical looking.
Right.
And then there's pogonip, which sounds a lot more
Yeah,
intense.
pogonip is a different beast altogether.
So what exactly is it?
Well, it's a type of frozen fog.
Frozen fog.
Yeah, so those tiny water droplets we talked about, the ones that make up regular fog.
Yeah.
Well, in pogonip, those droplets actually freeze into ice crystals.
Whoa.
But the crystals are so small, they stay suspended in the air. So you get this thick white haze that's actually made of ice.
So it's like fog, but made of ice instead of water.
Yeah, pretty much. And it tends to form in valleys and basins where the cold air kind of settles.
Okay.
And it can coat everything in this layer of ice. Trees, fences, power lines.
It sounds beautiful, but also kind of scary.
Yeah, it can be really dangerous, actually.
How so?
Well, visibility is obviously a big issue. It can reduce visibility to almost zero, which makes driving or even just being outside really risky.
Right?
And those tiny ice crystals, they can be inhaled, which can irritate your lungs.
Oh, wow. So maybe it's best to admire pogonip from afar, or at least wear a mask if you're out in it.
Yeah, I think that's a good idea. Okay, so we've covered these two kind of unusual types of fog, hair ice, and pogonip. But now let's talk about a type of fog that's probably a bit more familiar to most people, especially if you live near the coast. Have you ever heard of advection fog?
Advection fog? It rings a bell, but I'm not sure I could explain it.
Well, basically, it forms when warm, moist air moves horizontally over a cooler surface.
Okay.
So you often see this in coastal areas where you've got warm air from the ocean blowing over cooler land.
Right.
And when that warm air hits that cooler surface, it cools down and can't hold as much moisture anymore.
Okay.
So the excess water vapor condenses into those tiny droplets and you get fog.
So it's like the warm air is giving up some of its moisture as it moves over the cooler ground.
Exactly. And that's why places like San Francisco are so famous for their fog.
Right. It all makes sense now. Okay, so we've gone from hair ice and pogonip to good old affection fog.
Yeah,
It's amazing how many different ways fog can form.
it really is.
But we've talked a lot about how fog affects visibility.
Right.
Are there other ways it impacts our lives?
Oh, absolutely. Fog has a fascinating history. It's been intertwined with human culture and even military strategy for centuries.
Military strategy.
Really?
Oh, yeah. Think about naval battles, for example.
Okay.
Fog could be a huge tactical advantage, allowing ships to approach undetected or escape a losing battle.
Oh, wow.
But it could also lead to disastrous collisions, so it added this whole element of unpredictability and danger to warfare.
So fog wasn't just like a weather event, it was like a factor in these battles.
Exactly. It's like nature itself was playing a role.
I love that. So it had this like strategic importance in the past.
Definitely. But its impact goes beyond the battlefield, too.
Okay, how so?
Well, think about literature, art, music.
Okay.
I mean, how many spooky stories or mysterious scenes feature fog?
Right.
It adds this layer of intrigue and suspense.
Yeah, there's something about fog rolling in that just makes everything feel kind of eerie and mysterious.
Exactly. It obscures the familiar and makes you wonder what's hidden in those swirling mists.
Oh. And artists and writers have been using that to their advantage for centuries, creating atmosphere-building suspense, symbolizing the unknown.
It's like fog is more than just a scientific phenomenon. It has this whole cultural significance, too.
Absolutely. It's captured the human imagination for centuries.
That's so cool. Okay, so we've talked about history and culture. What about modern industries? Does fog still impact them?
Oh, yeah, definitely. Especially industries like aviation and agriculture.
Oh, right. I could imagine fog being a big problem for airports.
Yeah. Dense fog can reduce visibility to almost zero, which makes it incredibly dangerous for planes to take off or land.
Right.
So airports have to invest a lot in sophisticated instruments and landing systems to help pilots navigate through those low visibility conditions.
So it's this constant battle between technology and nature.
In a way, yeah. But fog isn't always a bad thing.
How so?
Well, it can actually be beneficial for some industries like agriculture.
Really?
Yeah, in arid regions, fog can provide a lot of moisture for crops.
Oh, wow. So it's like nature's own irrigation system.
Exactly. Those tiny fog droplets can condense on plants and give them the water they need.
That's amazing.
But of course, like with anything, too much of a good thing can be a problem.
Right.
Excessive fog can lead to fungal diseases and damage crops.
So it's all about balance, finding that sweet spot where fog can be helpful but not harmful.
Exactly. And that can be a challenge for farmers in areas that are prone to fog. They have to manage these delicate ecosystems and find ways to protect their crops from too much moisture while also taking advantage of the benefits of fog.
This deep dive has really opened my eyes to how complex fog
Yeah.
is. It's not just a weather event, it's this force that shapes landscapes and influences industries and even, like you said, inspires art and literature.
I couldn't agree more. It's a reminder that even something as seemingly simple as fog can have these profound effects on our lives and the world around us.
And speaking of profound effects, you mentioned earlier that light interacts with fog in these really interesting ways.
Yeah,
I've seen pictures of sunrise and sunset where the colors are just like amplified by the fog. It's incredible.
it is stunning, isn't it?
So what's the science behind that?
Well, to understand that, we have to talk about how light interacts with those tiny water droplets in the fog. So those tiny water droplets, they act like prisms.
Prisms, like the ones that split light into a rainbow.
Exactly. So when sunlight hits those droplets, it gets scattered and separated into its different wavelengths,
Okay.
and we perceive those different wavelengths as colors.
So it's like fog is creating a bunch of tiny rainbows.
You could think of it that way, yeah. But instead of seeing like a distinct arc like you would with a regular rainbow,
Right.
the colors are kind of dispersed throughout the fog.
Okay.
And that's what gives it that ethereal glow.
That makes sense. And I've noticed those foggy sunrises and sunsets often look really warm and golden.
Mm-hmm.
Is there a reason for that?
Yeah, it has to do with the different wavelengths of light get scattered.
Okay.
So longer wavelengths like red and orange, they don't get scattered as much as shorter wavelengths like blue and violet.
Okay.
So during sunrise and sunset, when the sunlight's passing through more of the atmosphere, those warmer colors are more prominent,
I see.
especially when there's fog.
That explains why those foggy mornings feels more magical. It's like the whole world is bathed in this warm light.
Yeah, it's really beautiful.
Speaking of colors, though, I've also seen fog that has kind of a yellowish or brownish tint to it.
Uh-huh.
Is that pollution?
That's a great observation. And yeah, you're on the right track. The color of fog can actually tell us a lot about the air quality.
Really?
Yeah, so if you see fog with a yellowish or brownish tinge, it often means there are more pollutants in the air, like dust or smoke particles.
Mhm.
And those particles absorb certain wavelengths of light, which gives the fog that off-color look.
Wow. So it's like the fog is acting as a filter and the color tells us what's in the air?
Exactly. It's pretty amazing how everything's connected in the environment.
I know. This deep dive has been incredible.
Yeah, it's been fun.
We started with these tiny water droplets and ended up talking about everything from history and art to military strategy and agriculture.
It's a pretty broad topic when you think about it.
It is. I feel like I have a whole new appreciation for fogs now. It's so much more than just a weather event.
Definitely.
It's something that really shapes our world in so many ways.
I couldn't agree more.
Well, I think we've covered just about everything there is to know about fog.
Haha, almost.
So for those of you listening out there, the next time you see fog rolling in, take a moment to really appreciate it. Think about all the amazing science and history and culture that's wrapped up in those swirling mists.
Yeah, and pay attention to those little details, the colors, the way it transforms the landscape, how it makes you feel.
Because sometimes the most fascinating discoveries are right there in front of us, just waiting to be uncovered. Thanks for joining us for another deep dive. We'll see you next time.
Sure.